Welcome and thank you for attending Toxicity Assessment in Water, Best Biomonitoring Practices and Technology to Provide Real-Time Status of Drinking Water Quality. This webinar is presented by Dr. Detlev Lohse. Dr. Lohse studied biochemistry at the University of Hanover, Germany, and received his PhD from the University of Dusseldorf in 1986. He spent more than 10 years in fundamental research specializing in plant biochemistry. For more than 22 years, Detlev's focus has been on knowledge transfer regarding photosynthetic processes and algal pigments. So I'll let Dr. Lohse take it from here. Thank you.
You perhaps read my foreword, and thanks, Carrie, for this working on it. And when I saw this, I just tried from another way, other side. I got some of these news from Fox Radio, yeah. And when you listen to Fox Radio, sometimes it seems very dramatic what they say. For example, is water safe or isn't it safe? Yeah. So from this message, you can conclude water is unsafe. But I think that is not the whole truth. You can ask, what does it mean? Is it safe? In what way is it safe? How much does it affect human health, for example? And therefore, I would like to talk today about toxicity in water. And for this, I have prepared presentation. I hope you can see this. Yeah, it's toxicity assessment in water, and we have a very personal view on the toxicity assessment in water because we provide instruments and techniques which are applied now for, let's say, almost 30 years. And it started at the outspin of a university in the early 80s or late 80s with Christian Moldaenke, who is also the owner of the BBE company. And they tried out to use algae to determine the health and the quality of the water. And today I would like to introduce a little bit about this work and how it is used nowadays. And of course, I have to give some definitions. But before I do this, I would like to tell you something, what we understand, what toxicity means. And as we want to determine toxicity, I have to talk about, about biomonitoring and have to compare this, for example, to chemical work. And we have also to compare this to something that we call dose response effects. It means that we have to deal with the concentration and side effects of these potential harmful compounds. Then I would like to introduce a little bit about the organisms that are used in biomonitoring. Here I have, let's say, the most common organism that we also use in our instruments, but which are used worldwide, and ask what is a suitable organism to detect toxicity. And what is important is that when we have toxic events, how can this alarm recognized? What is behind of it? So this is it's a composition of different types. What we have the water on one side with a good or poor quality. We have a biomonitoring system like organism, and we have an instrument that is able to detect something, and then it should be also a software which recognizes that it is an alarm situation to take management actions. And with this information, we come over to the second part, which means the application of different toximeters. I would like to give a short overview about examples. It's very short one because I just want to deal where it is used, what it is used for. And at the end, I would like to give you an information what is going on now worldwide with our instruments, with our toximeters, how they are used. And I think we are still one of the rare companies that provide complex solutions in biomonitoring. So I think, it's our hope that we can also extend this knowledge and its use in US America. Okay. Yeah, acute toxicity. That is the main thing that we would like to talk about. Acute toxicity means that it describes harmful effects caused by contact with hazardous substances in a short time. So that means short time after exposure, you can already see an effect on the organism, like it may be on skin irrigation, on skin, for example, or it can also be death of this organism. This is in contrast to the, let's say, chronic toxicity, which is only visualized after a long-term exposure. So, which means acute toxicity is recognized in hours or minutes, hours, or within a day, while chronic effects need, let's say, for example, um, um, liver diseases, for example, days or months until you can visualize them. So here we look for acute toxicity inside of the water, which should be, of course, very fast recognized because of its strong effects. And what we here have is, of course, we have different types where we have this toxicity assessment. Here we focus on water, especially. Water is used everywhere. It's essential for food preparation, drinking water, and so on. And poor water quality, of course, can cause infirmity, disease, or in a very bad situation, also the death of the organism. Of course, first we look for human health as a supplement of all organisms, but it's not only on that. I will give you an also example of other of other organisms which also can be damaged by the quality or the poor quality of water. And if we see here in the center a human being, and when we look around here, that there are some organisms which are already used to monitor the quality of water. And what you see here is I have on the left side, we have the algae, for example. We have here a fish. This is a zebra fish, very common also for the genetics. We have here a waterfly and very common in Northern Europe. And here we have luminescent bacteria. We'll come back to this, but all they can help you to understand what is inside of the water, if it is can pose a risk also to human being. If I looked for these organisms where they are in the phylogenetic tree, you see that algae are here at the lower part of the tree. Of course, we do not want to use plants for our tests. We would like to use small organisms which can be widely distributed in a water, because we want to work in the water. But we can also use animals like here, like these water fleas and also the fish. So when we look for this, these are quite different organisms. When we compare, for example, these, they have another stage of evolution because they could not develop nerves, for example. So if we have harmful compound inside, this cannot be easily found or detected with algae. But if we look, for example, for neurotoxins, they may much better affect fish, which are vertebrates like a human being, and Daphnia might in between. But I will come back to this because there are a lot of investigations on that. What is the right, or what is the very best one for the biomonitoring? And I will tell you how this test can be performed. So what you see here is a so-called static test. It seems to be very simple. Here we have also again the water fleas called Daphnia. Daphnia magna is used here. They are brewed here in a beaker, and then we have different dissolution steps here. And the Daphnia are added at a number of 10 or 20 organisms, and after a certain while, the observer, the investigator, looked how many of these are, let's say, immobilized or died from this. And when we have here, let's say, for example, as test concentration, you see the more you have, you can see the more immobility you can find. And usually it is estimated either the lethal effect on 50%, for example, then we come here to a value that is here in this range, here in between. So then we will find something about, let's say, 35 milligram for this example. So this takes time, because between start of this test, it takes time, let's say 4 hours, 48 hours, or 98 hours, until you get the results of this test procedure. So the advantages of such a test is that you have, of course, observe real toxic effects, and with the right organism, you will have a high sensitivity. And of course, we prefer also to use such tests, established test organism, maybe different stains which are really established from the genetics. So the disadvantage is mainly you have only one parameter, for example, immobilization or lethality of this, or for the algae, look for the reproduction rate, which how many reproduce during this time, and if the reproduction is affected. The other thing is you can only get discrete samples, let's say from a flow. When you want to observe a flowing system, you take discrete samples, bring them to the laboratory, perform this test, and get the results after a while. So that needs a certain time. Yeah, you understand that is something which is can be advantageous, because you cannot react on time. Yeah. Okay. I have to break. I will be back in a moment. Please excuse me, but I have to go to the door. Sorry about that.
Follow up with this foil, actually. Can chemical analysis replace biomonitoring? Main problem is the chemical analysis detects only substances we're looking for. It's not a system where you the raw water, you just get some substances and analyze them. You need hours and days if you do it in laboratory, and that takes a lot of time, and that is so days. Great examples you can
So
situation.
I'm back. Yeah, I'm back.
Time. This
Yeah.
already.
Did you explain it already?
Yes. You can.
So we can go on.
Yes, with the next point.
Yeah. All right, that's good to hear. So you know that today we have high or we have superior instruments that are used, for example, HPLC mass spectroscopy, very costly instrument, and also it takes time. What I would like to show you is that there is another effect which you cannot see by chemical analysis. This is the activity or the response you get from such mixture. If you have, for example, have cofactors inside your water sample. Those cofactors can be, for example, other pesticides which have a different target, and they cooperate maybe in this way. And what you see is that now the response does not follow only the pesticide concentration, but is also affected by cofactors. Cofactors can be, for example, carbon dioxide. It can be a changed pH, for example, where something gets more active and so on. So that what you see is the effect does not really depend only on the pesticide concentration, but also on a combination of a secondary or third cofactor in the solution. And the chemical analysis will only after, let's say, gas chromatography or mass spectroscopy combined with this gives you only the concentration, but not the toxicity itself. So what we need is that we have to determine a toxic event with a biomonitor. And of course, yes, we know toxic substance in water will lead to an extraordinary behavior. And this is the idea of what we had when we started up with our first biomonitor. And of course, the consequence is that when we have, let's say, a certain threshold, over a certain threshold, supersede a certain threshold, then we should get an alarm. And here we have one of the instruments. It is with the Daphnia who are swimming in a chamber here in the back of this, and this is visualized here on a screen by a CCD camera, and it is analyzed for changes in the different parameters, for example, speed and so on. And we follow up this swimming behavior. And if a certain value is superseded, then it will give an alarm, and the system itself analyzes also if it might be a true alarm or a false alarm. So that means this could be automatized in that way that it is part of a network. And we have also, of course, hardware supervision for that. That is just an example what is widely used here in Germany, Netherlands, and Northern Europe. Here we use the water flea. I have the water flea is insofar a good organism as if you look for literature toxicity, you find the most publications on this test organism in the world. So there are many thousands of publications that deals with the with the behavior and with the lethality and so on, with Daphnia magna, the water flea. Another large group is algae, of course, and here is dominating the so-called Chlorella vulgaris. It is a very common algae, very easy to grow. But we have also fish here in this. So I mentioned this. Maybe that in US America, fathead minnow is more common than here in Europe. Here we have, for example, zebrafish. I can also show you some other fish that are used, for example, Sumatra barb or tiger barb. Vibro fishery is mainly used, let's say, for sewage plants. It's not that not sensitive, but it might be the right organism for your purpose if you want to determine sewage water. It's not so sensitive. And of course, we have local solutions when availability of this organism is an important point. So when you think that there is a fish in your location which is very sensitive for your application, it might be the better choice. This is a report which I got from the European Union. There is a European Commission, perhaps you know. We are cooperating in Europe in many countries, very close together, more than 26 countries. And this was a big investigation about the sensitivity of different systems. They used around about 700 sets of chemicals. They analyzed with different types. Well, it is just only an overview because it is not said in all cases which kind of fish they used. It is not said which algae are used in all of these investigations. But what you can clearly see, they've tried out with the sets of data to find what are the most sensitive systems. And what you can see here, the algae are the most sensitive systems used here in reproduction. So that algae are very broad part of toxicity assessment systems which we can use. And so this is also, let's say, the first one we tried out here in Germany. And later on, we switched to Daphnia and to fish. So I would like to tell you something about this instrument because it is the last advanced algae toximeter provided by BBE. And I'd like to explain how it works. This green part here is the photobioreactor where we grow the algae. And the algae, you cannot see it here, are mixed either in a loop, which is behind a door. You cannot see that this is a door, but there is a loop where this is mixed with the algae culture from this bioreactor. And after the incubation, this is pumped via this pump head into the sensor. And here the reaction takes place. So the algae are illuminated. And when they are illuminated, they can make fluorescence, which is part of their photoreactant systems. So that means when they can do good photosynthesis, they will give a strong signal. But if the photosynthesis is affected, the signal is lowered. And this is a parameter for the health of the system. So you have mixed samples. So this is not completely continuous, but this is semi-continuous. So the mixed and incubated samples are pumped into the sensor where the analysis takes place. And then you get the results here on the screen, of course. And one sample takes, let's say, round about an hour. And what is the outcome of this? It is compared fresh water, unpolluted from a tank. It's tap water, compared to the value of sample water, let's say from a river, from a lake, from a drinking water system with the algae. So this means that we always have the quality of pure water compared to the water which may be affected by some pollutants. And the advantage is here, it is the sensitivity is rather high, but it is not always that high what we have, for example, with Daphnia or with fish. In sometimes, as you could see, the sensitivity is higher. But for certain substances, of course, it's very high. When you have, for example, herbicides inside of your water, it will be detected at a very low concentration. But the advantage of this is it react on a very broad range of chemicals which might be inside of the water. So response time of the measurement is although is rather short, but the incubation takes time. The molecules might approach might approach the center of attack, for example, and then affect the organism in total. Yeah. So the range of pollutants I've mentioned already, that is something which we have to deal with. So it might be also very good to complete such a toximeter with another type. Anytime what we can say, these algae are easy to grow. That means availability is rather good. This might be different when you switch to other organisms like fish, which might be not available over the year. So algae are easy to breed, especially this type. And of course, what I have to tell you is something about the operational costs, of course. Well, what you need is, let's say, around about 3 hours per week. And the cost for the chemicals might be 2,500 euros. I do not know actually what is with your currency, but maybe a little bit more. All right, this is what you have to spend within the instrument. And it's working, of course, automatically. It works all the time, at least 1 week with this photobioreactor, but then we recommend to exchange it so that it will not get polluted with other algae outside. And of course, we provide in the beginning these algae strain, which is clearly defined. with a high sensitivity. Additionally, we can also use, besides a test system, where we add a certain amount of a herbicide to visualize the sensitivity of this instrument let's say every 10 times when you measure this. So this is the algae toximeter, and it is the first instrument that we produced in our factory for such a toxicity assessment. The other one, what we have is here.
Participant has joined the meeting.
Yeah. It is a Tox Protect. It is a fish toximeter. And here we have different fish. And what you see is a scheme of it. The scheme of it, the water comes here inside the sample water. It is a real flow-through system. It is brought to an ambient temperature. Usually we use 20 degrees. And it comes into a tank where we have the fish. And the fish is swimming around. And here we have light barriers that determine how many times this fish crosses these light barriers, and the activity is counted. And with these light barriers, we can also determine where they are, not what is their activity, if they are in the upper part or the lower part. When the poor quality water comes inside, the fish tries to escape to goes up to the surface. Yeah, and but we have also the case that the fish is dead and may swim dead at the top of this tank. So then this is also a dramatic effect. We have a reduction of the crossings, of course, but we can check this again by another type, I will tell you. And then the water leaves, of course, the tank. We have an automatic feeding. We have illumination. During feeding, this is interrupted, of course, otherwise we would have high activity. And we have the measurement here on a PC. So when let's have see such an effect, which was measured with salt, with a harmful salt. Here we have potassium cyanide inside of this tank, and we measure the response time in the presence of a certain cyanide concentration. And what you can see here, when we are at 0.5 ppm, then we have here a response time for about 25 minutes with this experimental approach. And with a higher concentration of 1 ppm, it goes down to around about 9 minutes. So this is a very harmful effect on fish. Of course, I can say this is an experimental approach, and Cofactor can also enhance or reduce the time, but I don't think that they will really reduce this time, because it's very fast here that we can see the effect on this. This is the experimental approach performed with another fish, which is a local fish here with the sun bleak. I don't know if you have this fish in US America. What is important to know is that we want to know if this is a real alarm. So we introduced a alarm verification, and this alarm verification goes in that way. We have this illumination period which we added. Means usually when you have a fish tank and you switch off the illumination, then this leads to a change of the movement. And when you switch off and on again, you see another movement. And this is what we would like to recognize. If this will lead to the changes and bring it up to the normal activity again, then of course we say that is not an alarm. But if it stays in that way, then it is probably a real alarm. And so we have a verification of the situation that there is probably a harmful compound in this tank which affected the fish. So the increase again of the activity leads to reject the alarm, and this can be continued. If you have such an accident, the fish has to be completely removed and start up again, because you cannot use these fish again for toxicity assessment, because they are affected then and will not, even if they survive, will not show the same sensitivity. So I will, at the end, I would like to tell you here some real event what we saw a few years ago. This is toxicity alarm in a tributary of the Rhine. Rhine is a large river in Germany. Here in the Netherlands, there is a measuring station on a boat. And during this accident, there was a release of pesticides for a high amount of chlorpyrifos. And this led to fish dead, fish kill here in many kilograms died from this. And here in this monitoring station, here in the boat, they have biomonitors. Here, one biomonitor that showed alarms. This is a two-chamber system, where in both chambers we saw an alarm. And later on, this was also evaluated by chemistry, where we determined here the content of pyrifos in a water sample. This is here shown by the red dotted line, where they can measure the amounts of this compound, of this pesticide, compared to a parameter which was determined by the toximeter. So you see that chemical analysis will anyway help to evaluate, but of course this took a lot of time later on to evaluate this, but the toximeter performed well. So when we have this now evaluated and we think we are on a good way, I would like to give you in the second part a short overview how these toximeters are used and applied worldwide. So we have this established application first started up with environmental monitoring. Here is our example, is the city of Hamburg. City of Hamburg has a port in industry, and let's say population about 3 million people live there. And in this area, they prepare also drinking water from the surface. And here we have waterworks in Constance. Lake Constance is the biggest freshwater lake here close to the Alps in Germany. And the waterworks, they take the water from the lake of Constance. Usually it's a very good pure water, but of course it can be affected by pollutants. By willful application, for example. So they use something like this. We see this also in food industry. We have here brewery Heineken. This water from the waterworks is used, of course, in the food industry. So it comes to this place and it comes up, and again afterwards it is used in wastewater. It is treated, the wastewater. And at the end, such a biomonitor can use to check if the water quality that is released again to the environmental, into the river, for example, is good enough or is still polluted. Yeah? And here we have the circle is closed and we are in the environment again. So what we have here now in the environment, this is the city of Hamburg. Here you see such a measuring station at the Elbe River. They have 9 automatized monitoring stations overall this area. And of course, close to the port. Here is the port of Hamburg, famous port. And they determine here with different monitors, not only with biomonitors, but also sensors for physical, chemical parameters. And here they have a center where they have the control over all these. So these data are collected and sent to a main station where they can do all this work, not only to survey the quality of the water, but also do quality check of the sensors, calibration, and so on and so on. So they have a really good network. It is recommended to visit it. I think it's the most advanced centers of the world that we have. Here, look inside of such a measuring station in the harbor area, and you see here in the back, you see an algae monitor. Here you see a monitor with water fleas, and when they have alarm, this water is here automatically collected in a water sampler where it can be used for analyzing. And they have here a ring system where the water flows through and is pumped into the different monitors. Here, this is a look around in this station, a short movie, so that you have an idea. The Daphnia 2 chamber instrument, we have it here, also the algae toximeter, and that's it. So when we get out the different signals, we have here sum up all of these different parameters they get from the different systems, and they are combined. Now it is a combination also from the physical chemical sensors together with the biomonitors to evaluate and find out if it's a real alarm and what is affected. Another part is at the Rhine River upstairs. It is a solution for collaboration with a chemical factory. BASF is a very famous factory, make pharmaceuticals, dyes, for example. And they, in the past, they had some problems because in 50 years ago, it was not a problem to release some polluted water into the Rhine River. It was why it was the most polluted river in Europe. But when this country started up with a monitoring station, the situation get much more improved. Now they have different biomonitors here in this measuring station where they determine toxicity with different parameters. And they also perform some interesting collaboration with this factory, because they have the library of all the compounds that are used in the factory, and they perform also chemical analysis to find out what comes into this water so that they can early take management against this pollutant. We have here the drinking water system from Lake Constance. You see also a monitor here with the water flea. We have in an area rich in forest where they brew the famous Warsteiner. But we have also such an instant for such an toximeter used here in Brazil, where the Heineken started up with a brewery some years ago. It's not that they would like to go for always from the Netherlands to Brazil and import the beer. They make the beer by themselves in Brazil now. And we have here close to our place here, water treatment, effluent control. This was just a system to evaluate if it will still work here. When the water is purified during the system stages, then it will release in the bay of the Eastern Sea, of the Baltic Sea. And this was checked here with water effluent control by toximeters. So this is an example where we saw that this is a normal event for when we see this organism react on this. But here, this was a misoperation with the flocculation process. So they gave too much of this flocculation agent into this, and the system reacted on this. It was not a real pollutant, but of course, it is a pollutant when they add aluminium chloride into the water, and this will also come into the Baltic Sea, and this is of course an unwanted incident. Another example what I like to give you shortly is a very advanced country that is in South Korea. In South Korea, they have a lot of sewage treatment facilities where they survey the water quality, more than 1,000 that you can see of them. I just want to tell you that around 100 of these are surveyed also by biomonitoring systems. So we have a lot of biomonitoring systems already in South Korea. So they are very advanced in that way. And here in Germany, we have mainly at the large rivers. Yeah, you see here, that is the Elbe River. This is the Rhine River that goes also here through the Netherlands into the North Sea. And we have another, the Weser, which is also surveyed by this. And we have neighbor countries here, for example, we have in the Czech Republic, which is surveyed with the Danube River. We have also here in Austria, some of them in the Switzerland, where they have water supply survey. You see many countries here are equipped with such biomonitoring systems. And these are the big rivers which we have here. Just to show you here, this is the Meuse, a tributary of the Rhine River, where they had this spill with this pure pyrophos accident. So when we look around, then we can see we are rather successful, I think, with these toximeters. When you look for them, we have now more than 300 BVE toximeters installed worldwide. Many of them, of course, are in Europe, but I think equivalent part of it is also in Asia. In America is not that well established, although we started, I think, almost 20 years ago when we had the Olympic Winter Games in US America. We could equip with some toximeters, but this was only for this purpose. So I think we have a system, or we offer systems that can be used worldwide. And of course, we hope that this technique will also find its way to US America again. And I think this way to survey the quality of water gives you, let's say, a very advanced technique that can run automatically, but of course needs some introduction into this technique. And I'm quite sure that our partner, PP Systems, can help us in this way. We had some toximeters. We are not allowed to talk about this at this moment, where they are and where they are used. But I think we see that there is a raised interest in this kind of toximeters. I hope that this was informative for you, and I thank you for your attention. Yeah.
Well, thank you for that, Detlev. That was great, and I love the illustrations.
Yeah.
Does anybody have any questions here? Detlev, can you see the chat to address any questions? We have one from John Canning, who said, on the ToxProtect 64.2 instrument, what is the potential consequence on system performance, fish response, if the water heater is not used and the water temperature varies seasonally from 4 to 22 degrees Celsius?
Yeah, well, usually we try to bring this to an ambient temperature, of course. That means that we have to do a sample preparation. Yeah, that means usually we have heaters. It can help, but sometimes we know it can raise a problem when the water is too hot. What we need is we need around about 100 liter per hour. Yeah. And so we may use a very efficient cooling system, and this can be a problem, of course. It's quite right. What you can do is you can use a different fish. So what we know is, for example, we have here in boreal systems, we have more cold water fish. But you can also warm water fish. For example, zebrafish, which is very common. Yeah, it can be used, let's say, to 28 degrees Celsius. Yeah, and then you are not far away from the value that you mentioned. So that the cooling system must not be so strong to reach the wanted temperature for performing these tests. On the other side, it is quite clear when we use cold water fish, the activity of the fish usually is a little bit reduced. They do not move so fast. Yeah, that means reaction of the fish is reduced, and this can also affect, of course, the sensitivity. So it is, let's say, looking for the right solution. Yeah, the biomonitor is one thing. You have the equipment on one side. When you have a when you have a high flow, it costs a lot of energy, for example, to reduce the temperature. When you use another system, for example, an algae toximeter, then you have the time. Yeah, you do not need a high amount of sample. For example, the sample loop, what I've talked about, is, let's say, less than 100 milliliters. To bring 100 milliliters to an ambient temperature for the measurement, it's not really a problem. Yeah, and what we have also in, for example, what we see in South Korea, they have systems where they have chambers where they have air conditions, for example. Yeah, so they are cooling the whole system. You know that, for example, in a measuring station outside, it has let's say it is a simple measuring station with a simple roof, and the sun burns to this housing. Yeah, you can get very high temperatures. So then it is a problem of the room itself, and so therefore air condition can help to reduce the temperature. But it's quite clear in our specs. We can say when we offer such an biomonitor, we say the temperature should not supersede, let's say, I don't know, 35 degrees ambient temperature or sample temperature, then it will become a problem. But of course, we would like to know, and before we install such an instrument, or when we plan to this installation, then we send to our customers a questionnaire about the conditions. What are the conditions in your place? Yeah, what is the temperature? What are the electricity? What is the temperature of your water? What kind of water do you have, and so on? That is essential to know that it will work properly when we install the system. So therefore, please contact us for this and tell us what are your specs, what you expect to have, and we can give you an answer and find a solution together with you.
Question was more or less if you have, for example, in notes of.
Okay, does that answer your question, John?
Yes, I think the big picture I got out of it was that there's a potential for reduced, slower fish response during colder temperatures or colder water temperature if we're not employing use of the heater. So it's something I'm going to look into and consider.
Okay, there's another question. Is it possible to switch the fish species at various times of year when the water temperature changes, or is that not recommended?
No, it's not recommended, because when you start up, you need to determine their normal behavior. And when you switch from one fish species to another one, you have also to start with this again. And consider, please, when the main work with the fish toximeter is not the fish toximeter itself, it is breeding the fish. You have to have the fish in another tank to provide this fish for all the time when you need it. And then you may have 2 or 3 species of fish side by side. It is a lot of work. I think to make it easy, please select this one, which is the most proper system that you have. And if it works, don't switch to another one. Yeah, it will make a lot of work, and probably it will also will make the analysis more difficult. Yeah, then there is also a lack. Whenever you switch or whenever you start, with this fish in a new tank, for example, you have a gap where you cannot analyze a toxic event, because it means you have to start up to see their normal behavior. And after this period, this alarm system is adjusted, yeah. And what we look is for the change of the behavior, yeah. And so that means it is compared to that what normally happens with the fish in the tank, yeah. And whenever you start with this one, this should be normalized, yeah. And therefore I think it is not good to use different, or you use different fish toximeters. It might be the choice, but I don't believe that there is affordable solution.
Okay. Okay, does anyone else have any more questions for Dr. Lohse?
I think you also can turn on your microphones if you have some questions. We are not that many people.
But if it's not the case in this moment, you can contact us anytime with a question. Later on, I know that is sometimes when you consider such a presentation, there are still open questions. Please contact us for that again. We will be happy to inform you. Even if you do not want to buy such a system, I would like to spread out the information about the system, because I think it's a very useful system that can be applied. It's not that we can say that our system is the only one that can be used. I've told you already that the luminescent bacteria can be very useful for different purposes, but for our system that we use, they are not very useful because they are not sensitive enough.
Okay. Yeah, and anyone who signed up through us, please, you can email me as well.
I do have one question, if I could. We've had success running the same set of fish in a ToxProtect 64 for up to 6 months without any mortality, and the fish seem fine. Would your advice be to continue that practice, or would you recommend exchanging the fish on a rotation?
Yes, usually we say it can kept in this tank for months, yeah. But what you do not know if there is underlying effect of barnacle accumulation inside of this. That means that you will not see it, and the sensitivity within this time can be decreased. We do not know how this effect works on your fish. What we say is at least, or what is, it's not our experience, it's the experience of our customers. They say that they use it, let's say 3 months, and then they exchange the fish against another one. And I think this is a good way to exclude at least this effect. Maybe that other thing also that I should mention, when you start up with a juvenile fish, yeah, then they are mainly more sensitive than adult fish. Yeah, that is also what changes with time. That is the reason why such fish should be exchanged from time to time. But it depends on that what you want to do. I can really give you a quite clear recommendation. But what we know, what our customers are doing, is that they replace them periodically. Yeah, I will give you a short information about this in the history. It's not allowed for animal welfare with German fish tests, which were used formerly. It's not allowed anymore because it is an animal experiment. But to perform this animal experiment, they used a fish that is called Leuciscus. And this Leuciscus was not available over the whole year because they put the eggs on the ground only in certain seasons. So what they did here, they starved the fish. They gave not no food, and to keep them at a certain length, which was under regulation. So they can keep them and starve them, but it was as long for 4 to 6 centimeters, so they could perform the test, even if they know that this fish starved from hunger. Yeah, so clearly this affected, of course, the sensitivity for pollutants, but from the regulation, it was the prescriptive length of the fish. And they had this fish over the whole year. It is nonsense, yeah, of course, from my understanding. So therefore, I think the best way is to exchange a fish, but you should be sure that it is available all the year. And of course, in good condition. In good condition, that is also important. Yeah. Hmm?
Okay.
So,
Good. Thank you.
yeah. In Germany, in former time, they trained the fish. They trained the fish to swim actively against the flux, for example, to strengthen their muscles.
I'll have to try that.
Mhm.
Does anyone else have any more questions? Okay, well, thank you, Detlev. Great presentation as always. Once this video is ready, we'll have that available on our website, and we'll post it in LinkedIn and social media for other people to see. And again, if you have any final questions that you think of later, feel free to email me or BBE directly with those questions. Okay?
Yeah, thank you. Thank you very much.
Thank you. Goodbye.
Bye-bye.
Thank you.
Thank you.
Bye.
Bye.
Thank you for attending this webinar. To learn more about the Tox Protect 2, visit ppsystems.com.